Okay, so we're going to start section 7.1. So this is part one to the lectures. We're going to talk about integration by parts. And integration by parts is we're going to derive it from the product rule for differentiation. So you'll remember we had for the product rule, if we had two functions, f of x times g of x, we want to take the derivative. This was f prime of x, g of x plus f of x, g prime of x. And so what we can do is we can integrate both sides of this function. So we get the integral f of x, g of x prime dx is equal to the integral f prime of x, g of x plus f of x, g prime of x dx. This left-hand side, by the fundamental theorem of calculus, the integral of the derivative is just stuff inside, f of x, g of x, and on this right-hand side, we're going to split up the integral. We're going to f prime of x, g of x dx, plus the integral f of x, g prime of x dx. And we're going to solve for this one. So what we're looking for is we're looking for an integration formula that lets us, find the integral of one function times the derivative of another. And so this tells us that the integral of f of x, g prime of x dx is equal to f of x, g of x minus the integral f prime of x, g of x dx. And this is the integration by parts rule. And you can look at this and you can tell that this is super unwieldy. It's not very useful. So we're going to change the notation a bit. We're going to let u equal to f of x. We're going to say v is equal to g of x. And so from this, you can get dv is g prime of x dx. And if you look back, so I know it's not super easy with this Zoom thing, but if you look back, here we have g prime of x dx. This is u. So that first one then is, so we have the integral. No, that's fine. So we have then that left-hand side is the integral u dv. And so let's look and see what we have here. F and g are u and v respectively. So this is equal to uv minus the integral. So here we have f prime of x dx, and that is going to be du. You can check here. So this one ends up, so you have uv minus the integral v du. And this is the form that it takes most often, and this is the easiest one to remember. Integral u dv is uv minus integral v du. Legitimately, that's just one you have to memorize. So the point of this strategy is it's going to let us it's going to let us figure out these new integrals by strategically picking what u and v are. So I'm going to do an example, and this first example, so you're not going to be able to identify why I'm using integration by parts. I'll cover that. I'll show you when you want to use integration by parts, because that's half the battle in this course is knowing which integration rule to use when. So let's do our first example. So we have example 1. Find the integral x sine of x dx. So we have our solution. Okay, so you can look at this and say, okay, I don't know any antiderivative for this. It's not a u substitution because there isn't really any good thing I can pick for u substitution. So we're going to try integration by parts on this. So we have the integral x sine of x dx. And for integration by parts, what you do for this one is you pick u and you pick dv. And from that, you figure out what du and dv are, and you just write out the formula. So for instance, we're going to pick u and we're going to pick dv. And I'm going to go ahead and pick them the first time, and I'll explain why I pick what I pick. So for u, you can pick, anything you want here that isn't the differential. You could pick x sine of x, you could pick x, you could pick sine of x, you could pick any of those things. So I'm going to pick u to be x, and then dv is going to be everything that's left over. So if I ignore the x here, the things that are left over are sine of x dx. And now I need to get du. So I look at the differential of du, and I get just dx here. And dv, I'm going to integrate that, and that'll give me v is equal to, so let me go ahead and be explicit the first time. So v is the integral sine of x dx. So this tells me v is equal to negative cosine of x. So I'm going to make a new page, and I'm going to rewrite this just because I'm going to give you an easy way to remember this formula. So we have the integral x sine of x dx. We have u is equal to x, du is equal to dx, dv is equal to sine of x dx, v is equal to negative cosine of x, and then no more dx's. So the way I remember this, or the way I did it first, so we know that the integral u dv, and again, I've identified u, I've identified dv, so I'll write it down. So the integral u dv is u times v minus the integral v du. So I write this, and so I write the u dv du v in this way on purpose, because now I just have to remember that this integral is u times v minus integral v du. So it goes this way in this chart, and that's how I remember it. So the integral then x sine of x dx is u times v, so you're going to get negative x cosine of x minus the integral v du, and now you go minus cosine of x dx. Sorry, move those parentheses. And now you can see what we have here, it's a little more complicated than what we started with, and that's fine. So I have minus integral x cosine of x, and if I pull that minus sign out, I'm going to get plus the integral sine of x dx. And you'll see that, this first term here does not have an integral to do anymore. We've gotten rid of the integral. But now what we've done is we've come up with a new integral that we're actually able to do here. Yeah, so, sorry, that shouldn't be sine of x in there. Yeah, that's wrong. Yeah, so that should be a cosine in there. But now we can do this, we can still do this integral is the idea. So this is minus x cosine of x, and then I integrate cosine of x, and I'm going to get sine of x. Because I've done an integral, don't forget my plus c. And now that integral is taken care of. That is the solution to this one. So I'm going to stop the video here, and then we're going to talk about, when we want to do, or how we're picking my u and my dv. So I'll stop here and we'll continue.